Hi everybody. This is a video to talk about the last problem on the homework for Econ 180 for urban economics. So welcome to an urban economics YouTube video. So the last question asks you to look at one of the problems in the textbook. These problems can be a little bit mathematically complicated, but in the end there's always really great intuition, and so I really like to use them. So we are of course using our textbook, Lectures in Urban Economics, Jan Bruckner, one of my favorite urban economics textbooks. And so I'm going to just go over the problem briefly, and hopefully that gives everybody some insight into what's going on, what the problem's talking about, and what the intuition behind it is. So the problem starts with this idea that there is a chemical manufactured using some raw material. And the chemical X is manufactured using the raw material B. And the raw material B is located at the market. And so already we know what this problem is, right? This problem is talking about market orientation versus materials orientation. What we know is that producing 1 ton of X requires 1/3 ton of B. So that means that we're going to see it get bigger, right? It's weight gaining in production. So it takes 1/3 of B to make 1 ton of X. So it's lighter in the beginning and heavier at the end. So we'll add that into our understanding of it as we go. Everything else is pretty straightforward. The market is 50 miles away. Shipping costs the same amount regardless of the material, whether it's X or B. It's $2 per ton per mile. But there is a river in the middle of that 50-mile stretch between the market and the mine. And so there is a river 16 miles from the mine, and though the length of the river is negligible, you have to basically use a barge to get the material, whatever you're doing, over that river at that 16-mile mark. And so it costs $1 per ton to ship X across the river. Unfortunately, B is highly, what did they say? Barge operators, the input B is highly toxic when mixed with water, so barge operators must charge an extremely high price to transport B across the river. So transporting B across the river is $195 per ton. So it's much more expensive to barge B across the river than it is to barge X. So that's going to be kind of the sticking point here. And then what the question asks you to do in part A is to use the information above to find the transport cost minimizing location, and think about first, you calculate 4 main locations. So there's the market, there's the mine, right, our 2 endpoints. There's also the market side of the mine and the market side of the river and the mine side of the river. And so what you want to think about is this idea, and I like to draw these things, that we have some point here, right? So we've got the mine and the market, right? And in between those two is, let's say, 0 to 50 miles. You can see I've got my blue pen, so I'm already ready to draw the river. The river is 16 miles from the mine. So I'm going to put the river here. And this is at mile 16. And so we can use this, I think it's useful, to me at least, to see things graphically to help visualize them as we go into mathematizing them. And so we want to try and think about where would we locate our company. We could locate here at the mine. So maybe this is one location. We could locate right here on the mine side of the river. We could locate right here on the market side of the river, or we could locate at the market. Each of those locations is going to have, a different transportation cost associated with it. There's the transportation cost associated with getting from the mine to the river, across the river, and then from the river to the market. What's different about each of these locations is whether we're transporting X or B. So remember B is the input. So if we locate our factory here, we'll turn the B directly into X and transport X from here to here, then from here to here, and then from here to here. If we locate our factory over here in the market, then we will only transport that input, right? We'll transport the B from here to here to here to here. And so really one way we can look at this is we can create a formula that helps us understand the cost associated with that transportation of going from the mine to the river, and then from the river to the market. And remember, the cost on the land is going to be the same regardless of what we do, right? It's going to be $2 a ton a mile. The only difference is going to be, are we transporting 1 ton of X or 1/3 ton of B? The next big cost difference is going to be that river charge. Is it X going across the river, which costs $1 per ton? Or is it B going across the river, which costs $195 a ton? Does that kind of make sense? Oops, where are we? Visually, sort of. So let's take a look at how we would figure that out. If we have our firm located at the mine, let's kind of clear this out, at this point here, I'm going to call this the mine location point W, then that means at point W, at the mine, we are going to produce X out of B right away before shipping it. So what's that going to cost us? Let's see. So if we produce X at the mine, we have to ship X. I'm going to label all of these points. I'm going to label them, let's just call them I'll make them a little factory with a little smokestack. See, drawing is important in economics. Who knew? So I've got W, X, Y, and Z. Okay, so I have 4 potential locations for my factory at point W where the mine is, point X on the mine side of the river, point Y on the market side of the river, and point Z on in the market itself. At point W, at the mine location, the book says we want to produce, we have a contract, we have to produce 30 tons of our final product. So if we locate our factory at W, at the mine, then we're going to produce all of those 30 tons of X right away. So we're going to have 30 tons of X, and we're going to have to transport it 16 miles times 30 tons at $2 a ton, or $2 per ton per mile. So that's basically giving us the first 16 miles going from the mine to the mine side of the river is 30 times 16 times 2. Does that make sense? So let me get out my handy dandy calculator. 30 times 16 is 480 times 2 is 960. So going from here to here is $960. Then we want to barge the X over the river. It's going to be $1 a ton for X. We have 30 tons, so that's going to be $30 to get across the river. So that's another $30 there. And then to go from Y to Z, from the market side of the river to the market, those last remaining 34 miles, right? If this is 16 miles, this is 34 miles to get to 0 to 50. That's going to be, again, 30 tons of X times those 34 miles times $2 per mile. So 34 miles times 30 tons times $2 is $2,040. Oops, $2,040. Does that make sense? So what we're saying here is, in order to get, if we put our factory at the mine, we produce all of the X right away. X is bigger than B, right? It takes 1/3 of B to make a ton of X, so that's going to be heavier. But we save on the transportation costs over the river where the B is so toxic. And so we have $960 plus $240 or $2,040 for the transportation, and then $30 for the barge. So that gives us a total of $960 plus 30 plus $2,040, $3,030. Sound good? So that's our first choice. We could locate the firm at the mine, and it costs $3,030. What if instead we chose the next location? We chose here on the mine side of the river. Well, this stays the same because we'll produce X here. What's different is this part. Here, instead of transporting 30 tons of X, we'll be transporting 10 tons of B, which can be used to make 30 tons of X. Because remember, 1/3 a ton of B makes 1 ton of X. So that means this is going to be cheaper. We'll still make X here, so we'll still be barging the 30 tons of X, the final product, so it's only going to cost $30, but we're going to have a lower cost over here to get across that river, to get to the river. So now transporting the raw materials, the lighter weight raw materials, those 16 miles, we're only transporting 10 tons of B, $2 a mile for 16 miles. That's just $320. Everything else stays the same because now we're transporting B from here to here, and then we make X, and then we transport X from here to the market. So that means now we have a cost of $320 plus $30 plus $2,040, or a total cost of $2,390. So far, so good. We could also move the factory over here to the other side of the river. And this is where we're going to see more costs change. So now we're going to be transporting that lightweight input B from the mine to the river. But now we're going to have to put that lightweight but dangerous product B across the river. And it's going to cost $195 a ton to get it across the river. We have 10 tons of B to make 30 tons of X. So 10 times 195 is going to mean that that barging cost is $1,950. Does that make sense? Hopefully. So we transport B from the mine to the river at a cost of $320. Barging the B across the river because of that hazard cost is $1,950. And then we turn B into X, and it costs $2,040 to get it to the market. So now we have a new cost. $320 plus $1,950 plus $2,040 gives us a total cost of $4,310. Does that make sense? Are y'all with me? The last final location would be if we also if we put our factory all the way in the market. So we would have transport B from here to here, from here to here, and then from here to here. So that just means that the last part would change, right? Those last 34 miles would be transporting 1 just 10 tons of B instead of transporting 30 tons of X. So 10 tons of B at $2 a mile for 34 miles is going to mean the last leg of the trip is only $680. So the transportation costs way lower if we locate our factory in the market. But that river barge cost, because B is toxic, is so high that it really drives up the cost associated with moving our goods, producing B on the other side of the river. So if we locate at the market, we're going to have a cost of $320 plus $1,950 plus $680. That gives us a total cost of $2,950. So if we're keeping track, the mine location cost was $3,300. The mine side of the river was $2,390. The market side of the river was $4,310. And let's get it all on here. Let's do that. And then having it at the market cost $2,950. So let's put all those costs in. Let me get a sharper pen. $4,310, $2,390. So now where would you put your factory? If you look at this, it's pretty easy to see, right? It's the most expensive to put your factory on the river side, on the market side of the river, because you have to pay that expensive barging cost and a lot of transportation cost of the heavy output. The cheapest place to put your factory is going to be to put it on the mine side of the river. You move the lower weight input 16 miles, turn it into the less hazardous but heavier output, barge it cheaply across the river, and ship it to market. Does that make sense? So that's the big idea from this problem. Part B asks you to illustrate this in a diagram using the sloping graphs from figure 1.6 in the book. We went over that in class. I don't think that's the most important thing in the world, but just to remind you, it's this graph here, right? Where we look at the cost of shipping inputs versus the cost of shipping output. And the idea here is just to compare the cost of shipping the heavier input to the cost of shipping the lightweight output. But the reality is that it's a little bit more complicated because of that barge thing, right? That barging it across the river, and because B is hazardous, has a really big effect. So the last two problems in it that I ask you to do on the homework assignment, C and D, they ask you to explain this intuitively and then ask how a bridge would change everything. And so what I really want you to do here is think about the intuition behind this. What's the intuition behind where you want to locate? You want to locate at the location with the lowest cost. It's going to be a function of how that good is, both in terms of its materials and in terms of the finished product. And it gets back to what we talked about in class, right? Whether it is weight gaining or weight losing. In this case, we have a good that is weight gaining in production. 1/3 a ton of B makes 1 ton of X. So making X out of B makes it bigger. So it's getting bigger, so we want to produce it closer to the market. But that's not the whole story. There's also the hazardous nature of the input. So B is lighter but dangerous, and X is stable but heavy. And so because of that, we want to get the lightweight input as close as possible to market without engaging in that water hazard. And that's really what's going on here. And that's the big idea is, how do we do that? Well, we locate on as close to the river as possible without crossing the river, because crossing the river incurs that hazard cost. And so that's where we'd want to be, right? On the mine side of the river means we transport that lightweight input as far as we can before we reach that hazard at the river that makes it more expensive. If we were to take away the river or build a bridge over the river and we no longer have to engage in the risk associated with the barge, then because the good gets bigger when we produce it, because X is going to be 1 ton, it takes 1/3 a ton of B to make 1 ton of X, then we'd want to locate at the market because of that weight gaining nature. So think about, and so this is a fun way to think about things. It goes back to the question about the breweries and the wineries. And so think about how many breweries there are in downtown Sacramento versus how many vineyards there are. Breweries don't take a lot of space. Beer is weight gaining in production. And so it makes sense that we're going to have lots of breweries located around people. So they're going to be evenly dispersed around the population. Vineyards, it's important to make the distinction between vineyards and wineries. Wineries sell wine, vineyards grow grapes and turn them into wine. So a vineyard needs a lot of space. It is a weight losing process. So think about how many grapes it takes to make all the grape juice you need to make the wine. Think about the fragility component, right, which is more likely to spoil, a bunch of grapes that you're going to turn into wine or a bunch of bottles of wine in a case. Which of those is easier to transport? And so the idea there is it's much easier to produce the wine at the vineyard, where have the factory at the vineyard, at the land, and then ship the wine to the people. Does that make sense? So that's just another idea of how we see firms locate, and it's based on these decisions, these choices. The decision is based on these facts of the good, whether the final product is bigger or smaller than the inputs, which is more fragile, which is more hazardous, which is bulkier. Make sense? Hopefully that clears things up. Let me know what questions you have about the homework or anything else, and I will see you all next week. Thank you.